Hello and welcome back to the Harvest Manager Configuration series. In this chapter, we will be continuing our discussion on the Harvest Use Case Behavior Configuration. So how do we define the data of an entity? So let's refresh our memory from the previous chapter. We are tasked with creating a germplasm with the following information. So how do we define this within the entity definition? So defining the data property of an entity is as follows. The data property is a JSON object where the keys are the API fields for when the post insert or put calls are built or for creating and updating the entity. And then the values of each key are data item definitions. These will dictate or define what the actual values are for each API field that we have declared. Let's take the state, for example, in the germplasm entity. If we want to add this to the data of the entity definition, we can do it like this. So this is our data property in the entity definition, and as mentioned, this is a JSON object, and the keys are the API fields that will be used for inserting the germplasm record. So for example, we have state here for the germplasm state, and then to define what the actual value of this will be, we have to specify a type. And for example, here we have plain text as a type, and this type of data item requires a text value property. And in the text value property, we can define the actual value that will be added to the request body of when we're creating this germplasm record. So in this case, the state will be not fixed. So that is one way of defining the data for creating or updating an entity record. So how do we define the data items? Data items can be defined using a variety of ways. Some are defined by specifying static values, just like what we've seen with the plain text type. Some are defined by data retrieval via API endpoints. Some are defined by pulling data from data buckets, which we will be discussing more of later. And some are defined by stating logical or arithmetic expressions, for example, addition or subtraction. So these are just some of the ways that we can build the data items. So in this module, or in this chapter rather, we will take a look at some of these techniques and try to use them as we try to define the data that we need to be able to create this germplasm as part of the use case that we want to define. Okay, so let's go to the types of the data items. So all in all, in the current implementation, there are 10 kinds of data items. So we have plain text, plain value, API retrieval, data bucket, expression, scale value, name builder, parentage builder, generation advancement, and previous decisions. So in this chapter, we'll be taking a look at some of these, and we'll try to use those to build the data of our germplasm. So first off, we've seen this example earlier, which is the plain text. The plain text type defines a text value. So simply put, it's just a plain text. So we define it in the as a data item like so. So we specify the type as plain text, and then the text value will hold the actual text that we want to be the final value. So for example, here I have ABCD as the text value, and the result will be ABCD, which is a string or a text value. And then next we have plain value. So plain value, the plain value type is a more flexible version of the plain text type. This supports text, numbers such as integers or floating point numbers. We also have Boolean values such as true or false, and we can also define null or undefined values using this type. So to define a plain value data item, we use the type plain value, and in the value property, we just specify the value. So for example, here I'm specifying the value as true, which is Boolean, and the result of this will be this value, which is true. So I think that's simple enough, right? So that's plain value. Then next, we have API retrieval. So this type of data item retrieves data through an API call to the CB API specifically. And it offers flexibility by allowing data extraction via API. And it also supports standard API features such as filtering and sorting. So it's very flexible, and we can basically pull any data from the database via the API retrieval type for data items. For a more in-depth view on how this is set up, you can check out this documentation in Confluence. But for now, let's just look at the example in our presentation. So for example, here we have this data item definition, which is an API retrieval type. In the API retrieval type, we can specify a subtype, which in this case is single value, meaning we just want to take one of the fields from the result of this API endpoint. In this case, it's a search call. So we specify the API method as well, which is post the API endpoint, in this case, germplasm/id/attribute search. We can also add URL replacements, which in this case is needed because we have a placeholder ID here, and we want to replace that with the actual germplasm ID. So here we have a data bucket definition. So this pulls data from the planted data bucket. So later on, we will actually see what this means. But what this is doing is that it's replacing the ID in the API endpoint with the germplasm ID of the planted germplasm. And then for the API parameters, we're just specifying one parameter, which is a variable abrev. And we're just specifying it as a plain text, and the value should be origin. So during the search call, it will pass this parameter. So the variable abrev of the result must be equal to origin. And then based on the result, we'll just take the data value of that. And then an example result of this could be this one. So this is origin, which is the germplasm origin, and then it's typically a country name. So we're taking the data value of that, and it can be a country name. So for example, Philippines. So that's how API retrieval works. Up next, we have the data bucket. So we've been seeing mentions of this in the past few presentation decks. So what is a data bucket? So when we say data bucket, it's a collection of data, various data, which have similarities to each other. So this, when we use the data bucket type, we pull data from a data bucket. And so data buckets are an abstract concept in Harvest Manager, and it can represent various data sources. So let's take a look at the example here. You can see here we have type data bucket, and the bucket name is planted. So when we use the planted bucket name, this is actually info that is based on the actual planted material. So for example, we can take the designation of the germplasm that is planted on a given plot. We can also take, for example, the occurrence name or the experiment name, the program code, and other info that is related to the currently planted germplasm or the plot information. So that's how we do it. We specify the type data bucket, we specify the bucket name, for example, planted, and then we specify the field name. So this is the identifier of the data that we want within that bucket. So in this case, there is a designation data within the planted bucket, which is again based on the planted germplasm's designation. And the result could look like the following. And for a list of the bucket names that we can use in our harvest use case behavior configuration, we have a complete list of this in our Confluence documentation. So we have various bucket names here. For example, planted, which again comprises of data from the planted material. Or we also have new, which comprises of data from newly created entities, which later on we will see. We also have updated, similar concept to new. And then we also have build data, retrieved, and collection. So later on, we will be encountering these bucket names as we go with our example. So that's how data buckets work in our harvest use case definition. And there are also other data item types, but we will not be going through all of them since we won't really be using all of them in our in this series. So if you're interested to know, you can check out the documentation again, and we have samples for all of the data item types that we have available for our configurations in HM. Going back to the presentation, so now let's actually try to build the data for the germplasm entity here. So let's do this together. So let's take each of the data that's specified here and try to populate it in the data data property in our entity definition item. So first off, we have designation. So this again wants to we want to build a new germplasm name or designation based on the planted designation, and we append a suffix -b to that designation. So for designation, we can use a special type of data item, and this data item type is called the name builder. So let's try to type that down. So we have designation equal to the type name builder. So what this does is it invokes a internal name builder that will take a nomenclature configuration from the database based on the entity, and it will try to find the correct or the best matching config item within that configuration and build the new name or the new designation, for example, based on the pattern that is specified within that configuration. So later on we have a dedicated chapter for this, but for now let's just add this as is. So designation will be filled in with the name builder type. So later on it will be built based on a given configuration. So we now have one for designation. So let's just let's say I'll mark it bold to indicate that we're done with it, or maybe strike through. Yeah. All right. Okay. So next we have state, and for state, we can use the plain text since we're just expecting a text value, right? So for state, we can use the type plain text, and then use text value, or specify the text value, which has to be not fixed. So now we were able to tell this that the state will be not fixed. All right. So again, let's mark this with a strike through to indicate that we're done with it. All right, yeah. Next we have, we have the type. So for type, for the API, for the insertion, it uses germplasm type. So we'll specify it as germplasm type. And then for type, we just use plain text again. And based on the definition, it has to be segregating. So text value should be segregating. All right. Oops. All right. Okay. And then next, we have generation. And for generation, we have another special type that we can use, which is called generation advancement. So what this does is it takes the generation of a germplasm and it advances it by one. So for example, we specify the base as F. So if we have F or filial generations for a germplasm, and for example the planted germplasm is an F1, then the new germplasm will be an F2, and so on. So we'll just specify this as this one. And this is also available in our documentation. So if you want to know more about this generation advancement, you can check that out in our documentations. Alright, so let's just update this again. We're done with the type and the generation. Okay, so strike that out. And then next we have the germplasm name type. So in the post germplasm API call, it's known as name type, just name type. And then for the type, so again we can just use plain text. So let's just copy this and change it up. So let's change this to selection history, which is what is being defined here. So now we have the germplasm name type. And then finally, we have parentage, taxonomy ID, and crop ID, which is just the same as the planted germplasm. So for this, we can actually use the data buckets. So how do we do that? So to specify that, let me just move this around. It's getting quite long. So let's move it here. All right. And then let's move this closer. So let's start first with the parentage. So parentage, and the value should be same value as the planted germplasm. So again, I mentioned we can use the data bucket type for this particular data item. So data bucket, and then specify the bucket name. We can get this information from the planted bucket. So this is taking info from the actual planted germplasm. Then we specify the field name. In this case, it's parentage, so it's just parentage. It's just the same. Parentage. All right. And then we just do this again for the other for the taxonomy ID and for crop ID. So taxonomy DB ID, for example, for in the planted, it will be the germplasm taxonomy DB ID. Yeah. And then for crop ID, it's just crop DB ID, and we just take that and add that as a field name. Alright, so now we have the complete data for the germplasm that we want to create. So what's left is that, let me just actually show you what this will look like in the request body for post germplasm. So based on what we've specified here, this will be, there's a typo here, sorry, germplasm type. Yeah, alright. So based on the data here, this is what our request body for post germplasm will look like. So the designation will be whatever is the output of the name builder. So it's just a placeholder for now. For state, again, it's a plain text, not fixed, so not fixed. Germplasm type, segregating. Generation, we have generation advancement, base F. So for example, if the planted germplasm is F1, then the generation will be F2 for the new germplasm. The name type, we have selection history, again, plain text. And then for the parentage, taxonomy DB ID, and crop DB ID, it will be whatever is the same information for the planted germplasm. So that's how we build the request body when we are creating or updating a given entity. Alright, so now all that's left for us to do is to copy this and add this into our harvest use case definition. Harvest use case behavior configuration. So I'm just updating the germplasm type. I made another typo earlier, but yeah. So what I will do now is I'll copy this whole config item, and I will go to my pgadmin, and right now the harvest use case behavior is empty. There are no defined harvest use cases, but I will now insert the config item that we've just worked on. So now I'll try to apply this, and okay, successful update. And let's go to our sample occurrence from the previous chapters. So this is where we left off. Again, the harvest failed because there was no harvest use case behavior configuration found for this use case. So what that means is that Harvest Manager doesn't know how to process this because there isn't any definitions within the harvest use case behavior config. So now that we've actually added this, we can try to revert this failed harvest. So we can utilize the revert functionality. So just click on revert and click proceed, and this will update the status back to ready. So now we can try this harvest again, and we'll see if at this point it will be successful. So again, we have already defined the harvest data requirements config and the harvest use case behavior configuration. So do you think this will be a successful harvest this time? So let's try and see actually what will happen this time. So again, we create on the create button and click proceed in the confirmation modal to start the creation of harvest records. So after a few seconds, we should see the result, and so up to this point, the harvest will still fail. So this is expected. And again, let's go back to the harvest data tab and try to find out why this failed again. So we can do that again by clicking on the harvest summary and then checking the messages. So in this case, we have one error message, and it says here that no nomenclature configuration was found for the germplasm entity. So remember, in our definition, the designation, we are using the name builder type, right? So for the name builder to work, we have to define a nomenclature configuration for the germplasm with a config item that matches this harvest use case. So that's why the harvest still fails. So in the next chapter, we will be looking at how we can define the nomenclature config for germplasm so that the harvest will not fail. So stay tuned for that, and thanks for listening.